EBGP relationships are classified when we have a neighbor relationship between separate autonomous systems. That's the distinction. So when router 4 is peering with router 5, because these routers are in different autonomous systems, 65.0.10 and 20, different, certainly, we are going to have an EBGP neighbor relationship. By default, these routers must be directly attached. They must be directly connected. And why is that? Well, it is because if we were to crack open the insides of an EBGP packet, it would have a TTL of 1. What does that mean? A time to live value of 1. It would mean that it can not be routed, essentially. It means that once it is routed, it will decrement to 0 and immediately expire. And so if we were to insert extra routers in the mix, because we would have to cross extra routers, the moment that our EBGP communication gets decremented by 1, so I'll just do minus minus, which would be the programming symbol for a decrementation by 1. The moment that that happens, we would find ourselves in a situation where we are not seeing the packets. That first hop router would not route the packets. It'd be a problem for us, right? So we have to get rid of any extra routers in the mix or extend the BGP autonomous system so that we do have directly connected routers forming our neighbor relationship. And when you are an established peer, think about OSPF. When OSPF has a full relationship, that's a good thing. In BGP, when we are established, that is a good thing for BGP. And so when we are established, we're going to be receiving and advertising everything that we know about, unless we are performing some sort of route filtering, which is certainly possible with BGP.